Okay, sorry about that. I don't know what I was saying. Anyway, so AB is the diameter of a semicircle. Okay, right. Of center O and radius or. AC is a chord. BAC is alpha. Show that AC. Okay, so just because it says this diameter and we have a triangle and a semicircle, I'm just going to draw this triangle using the diameter and also using AC because that's what we want. Okay, so if I draw that triangle, I know it's messy, but there's a theorem that says the angle in a semicircle is equal to 90 degrees. So that means that's 90. This is OR, this is OR. So that means that side is 2OR. So that means the hypotenuse is 2OR, and this is AC. See, yeah, this works because if alpha is the angle, then this is the opposite. We know that this is the hypotenuse, so this has to be the adjacent. So adjacent and hypotenuse is cos. So the cos of the angle is adjacent over hypotenuse. That's the Ka part of SOHCAHTOA. So the cos of alpha is equal to the adjacent, which is AC, over the hypotenuse, which is 2OR. And then if I bring the 2OR up and multiply, I get AC is 2OR cos alpha, which is what I wanted. Show that the area of triangle AOC, so that's the original triangle, that one, is a half OR squared. Okay, so I think for area of a triangle, when it's not right angled, we have to do a half AB sine C. This can be A, this can be B, because the angle has to be in between A and B. So this angle here is going to be our C. So it's a half A now. Okay, I suppose I'll put it in. So A is 2OR cos alpha. B is just OR. And the sine of C is the sine of alpha. So that's do I keep the 2 maybe? Because there's a half here, so I feel like I might need to keep the half. I have the OR times OR, which is OR squared, and that leaves me with 2 cos alpha sine alpha. Okay, so I'm going to just go back into the formula and tables book and hope that that is one of the identities from the trigonometry part. Cos alpha sine. Yes, it is. Hang on, let me show you. Okay, so I'm back on that same page where I got the formula the previous time. Okay, so I'm here. So back from that same page, see this yoke here? There. So it's sine, like that's the same as that basically. So I can turn that into a half OR squared sine 2 alpha. And that's what we needed. It worked out fine. Show that the area of the sector OBC, so that's this bit here, is R squared A. Okay, so the formula for a sector, back into the formula and tables book, but this time I'm at area and just take the area of a sector formula, put it here. Okay, so there's the area of a sector. So, oh no, sorry, I didn't even get what I needed. So they are the formulas when the angles are in radians. I think we probably want them in degrees. So that's these. Okay, so the area is pi r squared theta over 360. Now theta is the angle here. So because these are both radii, which means this is alpha because that's an isosceles triangle. So that means this is 180 minus 2 alpha, because 3 angles of a triangle equal 180. And this line here, theta is 180 minus 180 minus 2 alpha, because a straight line has to add up to 180. So that means, what's that, 180 minus 180 plus 2 alpha. So theta is 2 alpha. Where does it say? I didn't check. Oh, look. Sorry, I'm using the degrees without checking. It says here alphas in radians. So I'm actually using the wrong formula. So the same one, the one for area, except the radians one. So a half r squared theta. Half r squared theta, and we now know that theta is 2 alpha. Half multiplied by 2 is 1, so that's r squared alpha. Sorry, the writing. Yeah. Okay, hopefully that's okay. So there was a bit of kind of old school geometry there. So the 3 angles adding up to 180. The straight line also adds up to 180. So I just did some subtractions, which eventually got me a version of theta. And then just be careful that we were told at the start that it was in radians, so you choose the right formula. AC bisects the area of the semicircular region. Okay. Show that 2 alpha plus sine 2 alpha equals pi over 2. So the area, that's the area of the sector. And then I previously got the area of the triangle. Yeah. So this triangle here plus the blue shaded sector, the area of the triangle is a half r squared, is a half r squared sine 2 alpha. And then the blue bit is r squared alpha. And if I add them together, they're equal to half of the semicircle. So a full circle, to get the area, it's pi r squared. So pi r squared over 2 for the semicircle. Yeah. Because it's half of the semicircle. And the semicircle is half of a circle. Okay. Ugh. Am I close? I think I can divide everything by r squared because there's an r squared in all of them. So I can divide this by r squared and it will cancel. I can divide this by r squared and it will cancel. And I can divide this by r squared and the r squared will cancel. Okay, so if I tidy that up, I have a half sine 2 alpha plus alpha equals, and this is going to be 1 by pi is pi and 2 by 2 is 4. Now, if we just concentrate on the alpha, it's supposed to be a 2 alpha. So if I multiply everything by 2, so if I multiply this by 2, I get rid of the half. It's just sine 2 alpha. If I multiply this by 2, I get 2 alpha, which I wanted. And then if I multiply this by 2, 2 into 2 goes once, 2 into 4 goes twice. So I get pi over 2. And that's done. Cool. Okay, we did question 4. We did question 5. We did question... Oh, we didn't actually finish question 6. So it says if the area... This was the one, do you remember, with the scale factor of 1.5? So if the area of triangle ABC is 20 square units, find the area of the enlarged one. So to go from a side in the little triangle to a side in the big triangle, you multiply by 1.5. So to go from the area of the small triangle to the area of the big triangle, you have to multiply by 1.5 squared. Okay, when it's an area, it's a square unit, so you have to multiply by 1.5 squared. So if this is 20, as it says it is, you're going to multiply that by 1.5 squared. And that will give us 45 square units for the big one. That's all that one was. Now question 7, you said you couldn't do it all, I think, so I'll keep going. Okay, so Mont Saint-Michel is an island located on the northern coast of France, just between Brittany and Normandy. During the 100 Years' War, the fort was of great strategic importance and the English were never able to successfully besiege it. The tides vary greatly between highest and lowest marks. The tides can be modelled using a sinusoid, that just means sinusoidal, just means that it has a sign in it. And it says H is the height in meters, T is the time in hours from midnight, and pi over 6t is expressed in radians. Find the difference between